let's apply the boundary condition and loading in this session. So I'll click on static structural. In context menu I will see environment tab. Under that we know that the first node point and the last node point is a fixed. So we'll click on the vertex selection. We'll select first node. We'll apply the fixed support. We'll select the last node. I will right click and we'll say insert fixed support. So both the way you can provide the fixed support, either from top context menu or by right clicking this option. So you provided a fixed support 1, fixed support 2. If you provide extra supports and you can see the question mark here, just delete that extra supports and question mark. Voila, boundary conditions. Next is we have provided the supports. Now we have to provide the loading. So at vertex number 2, here we are having a tensile load, right? So we have a tensile load of 49 kilonewton. So I'll select vertex number 2. We'll say force, and under defined by, instead of vector I will say components. So it's actually along this X component, right? So I will say defined by component and X component 49,000 Newton, right? So my unit is in Newton, make sure that. 3, at the point number 3 or vertex number 3, we have to apply the compressive load. So I will select this vertex, we'll say force, and we need to load of 20 kilonewtons. So I will say defined by component X component minus 20,000. Minus indicates reverse direction or compressive load. So we applied the force 1, force 2 and boundary condition. If I'll click on static structural, I will see all the loading and boundary condition. So up till now we have applied the actual loading and boundary condition. Let's apply the temperature rise. So from initial temperature and final temperature, the difference between two temperature is given in the problem as a 60 degrees Celsius, right? So to do that, let's assume that all these three bodies are subjected to the environment temperature of 0 degrees Celsius, right? So environment temperature is 0 degrees Celsius. Now I want to define a temperature rise. So I'll go to the loads, I will go to the thermal condition, and I will select bodies. We'll select all three lines by pressing Control. We'll see apply. So all three lines are selected. Now the magnitude I will give 60. So the environment temperature is 0, body temperature is 60 degrees Celsius. So delta T is equal to 60 degrees Celsius. So that what we are assuming here. So we have applied all the loading condition, temperature condition of 60 degrees Celsius, compressive force, tensile force, and fixed support at the both end. Now let's solve this. I will click on solve, and it's solved. You can see the green tick here.